In this video, we're going to talk about parts of the periodic table. So I'm going to go out to that periodic table that we've been looking at a few times. A copy of this is linked on Canvas. So if you've printed already, it would be good if you want to just pause real quick and go grab it. If you have the ability to print and you haven't, I would pause real quick and go grab and print it. If you don't have the ability to print, that's fine. We can just sketch one. I can do a rough sketch of the periodic table after I go through this. But remember that each one of these squares represents a different element, right? Elements are our fundamental substance that all other substances are composed of. And they're not arranged haphazardly on this table. They're in specific positions for a reason. So what I want to do in this section is just kind of go through and talk about the different sections of the periodic table. And I do want you to be familiar. So if I say, give me an example of a metal, you need to know where the metals are. If I say, give me an example of a transition metal, I want you to know where the transition metals are. So I'm just going to start dividing stuff out here. And the first thing I want to do is focus on this red zigzag line. So this line that goes through here. What this is doing is it's separating our metallic elements from our non-metallic elements, with the exception of hydrogen. Watch out for hydrogen here. Hydrogen is a non-metal. And the elements to the left of that zigzag line, with the exception of hydrogen, are metals. The elements to the right of that zigzag line are our non-metals, but you do need to include hydrogen. And then the ones along the zigzag line, so boron, silicon, germanium, arsenic, antimony, tellurium, these guys are semi-metals. Aluminum is an exception there. So if we go back to our notes here, we have metallic elements, and these are to the left of that zigzag line. It probably has an official name, but I never heard it. I just call it the zigzag line. But excludes. You'll notice that as we go throughout the semester, hydrogen's an example for a lot of things. If I just ask you what's an exception, hydrogen's a really safe guess. So metallic elements, these are to the left of the zigzag line, but we do need to exclude hydrogen. And metallic elements are just that, they're metals. So they have all the properties that you would expect a metal to have. So you can bend them, shape them, they're good conductors of heat and electricity, that sort of thing. Our non-metallic elements are non-metals. These are to the right of the zigzag line. But includes hydrogen. And then the properties, these are the opposite of that of a metal. So they tend to be brittle, not malleable. They're not good conductors of heat or electricity. And then we also have semi-metals. Also sometimes called metalloids. So depending on what book you've used in your chemistry past, you may have learned them that way. I generally call them semi-metals, but if you want to call them metalloids, it's perfectly fine. Both names are equally correct. And these are actually along. They're going to share a border with that line. But we're going to exclude aluminum. So excludes aluminum. Aluminum is a metal. I think most people, if I asked you, is aluminum a metal or not, you'd be able to tell me that it was. So it's not a semi-metal, it's actually a metal. Which you could get because even though it's along the line, it's to the left of the line. And the only exception there was our hydrogen atom, or element hydrogen. So the properties of semi-metals are really that. They're between that of a metal and a non-metal. So like silicon is a pretty well-known semiconductor. So it has properties that are both conductive and insulating, that sort of thing. So if we go back to our table, and I say, give me an example of a metal, you have a lot to choose from. If I say, give me an example of a non-metal, you know which ones are our options, right? Those are going to be, we'll get crazy with the highlighter here, those are going to be all of these guys and hydrogen, right? And then semi-metals, getting crazy with the highlighter, these are all of these ones. So again, just be familiar with the different sections and be able to give me examples there. I'm going to erase all this. The next section I want to talk about is we're going to differentiate between main group elements, transition metals, and intertransition metals. So I want to divide this up again here. So I'm going to take these first two groups. Oh, we need to define group too. And then I'm going to take these guys over here. So the ones that I put pink boxes around, those are going to be my main group metals. So groups 1A, 2A, or 1 and 2, depending on what method you want. And then 3A, 4A, 5A, 6A, 7A, and 8A, or 13 through 18. Those are going to be my main groups. So if I say, give me an example of a main group element, anything from those groups. If I say, give me an example of a main group metal, now you can pick from group 1 and 2, right, from here or here, but exclude hydrogen. Remember, that's a non-metal. Or if we go over to the other main groups, you could pick aluminum, any of these guys, these ones, or these ones. Remember, germanium and antimony are semi-metals. So for those of you that don't have a printed copy, we're going to make the most beautiful sketch of a periodic table you've ever seen. I'm being incredibly sarcastic right now. And these guys are my main groups. Sometimes they're called representative elements. The only time I ever use that term for them is when I'm teaching sections of the periodic table and I say sometimes they're called representative elements. I'm always going to call them main groups otherwise. So representative elements. Let's define group real quick. Hopefully, again, this should all be review for you. But groups are our vertical columns. So when I said group 1, I'm talking about this entire column, right? Group 2 would be this entire column. So my vertical columns, get rid of that messy stuff, are groups. There's actually 18 groups. And there's two different ways to number them. There's actually more than 18. We'll talk about that in a few minutes here. Two numbering systems, so we can just number them straight 1 through 18. And we'll go back to that periodic table and show you in a minute. Or there's what I call the AB method, where the main groups get an A designation. So group 1 is 1A, group 2 is 2A, and then over here, and again, I'll go to the periodic table, this would be group 13 or 3A if you're going to use the AB method. So going back to my table here, and we're going to erase this stuff again because it's getting really messy. Okay. So they're numbered up at the top. So 1 through 18, or the AB method, 1A, 2A, and then over here, 3A, 4A, 5A, 6A, 7A, 8A. So that would be my A block. And then the B's are in the middle. I do want you to know the A designations. Know that 1 is 1A, 2 is 2A, 13 is 3A, 16 is 6A, and so on. If you don't know exactly which of the straight 1 through 18 numbers correspond to the B block, don't worry about it. It's kind of weird. Like it starts with, that should actually be a 3. It starts with 3, and then it has like some that are lumped together. It's kind of weird, but just note that those are the B's. So when I say the AB method, let's actually change that highlighting. The ones that are highlighted in orange are my B block. The ones that are highlighted in yellow are that A block. We also have what are called periods, and periods are my horizontal rows. So going back to our table, these guys are numbered down the side here. Let's use green. So this would be period 1, period 2. Do note that it goes over to the other side. So hydrogen and then helium is also part of period 1. Lithium, beryllium, and then all of these guys are part of period 2. So they're my rows. This would be period 5. Do note that these guys down here, they don't have numbers on them, and I'll see if I can zoom in because it's kind of hard to see it, but they are actually part of periods 6 and 7. So if I can zoom in, if you notice there's an asterisk here, and if you follow the numbers along, 56, 57, and then 72, when you get to that asterisk, it goes down here. So 57, 58, and then 71 back here, and then back up to 72. So essentially, this is part of period 6. If you were to actually put it where it belongs, and the reason it's not there is it doesn't fit conveniently on a sheet of paper or even a poster. It would just be very long and weird looking. But this entire row actually fits right in here. So if you were to slash that open, expand it, that whole row goes in there. And then the same thing, zoom in again here, 88, 89, I have 2 asterisks, it jumps to 104. If I go down here, I have these 2 asterisks. So this is actually part of period 7. So when we get here, we come down, and then when we get here, we come down to here. Those last 2 rows, the displaced ones on the bottom, they don't actually have group numbers. So when I said initially that there was 18 groups, and then I said, well, there's actually more than that, it's because these 2, right, these guys down here, don't have group numbers. They have period numbers, part of period 6 and 7, but they don't have group designations. So periods are my horizontal rows. These guys are numbered 1 through 7, and then watch out for those 2 at the bottom, which we're going to give names to here in a second. So groups are my columns, periods are my rows. Main groups are 1 and 2, 13 through 18, or my A block if you want to use that method. The other designation we're going to have are transition metals. And transition metals are my B block. So if we go back up to this, these guys here are my transition metals. That's a horrible bracket. So my transition metals. If you have the printed version that you're marking up, this B block here. So these guys are my transition metals. The ones that we're missing yet are these ones at the bottom. Let's use pink, these guys. And these guys are my inner transition metals. I'll go back and write that on the notes in a minute. But the way that I remember it is, remember we said they fit in here? So they're called inner transition metals, and they fit inner the transition metals, right? If I was to cut this open and expand it, they fit in there. That's how I remember the name. So inner transition metals. That's the other designation. If we go back up, I didn't really draw them here. They're the two that are down here. Sorry, that's so messy. Inner transition metals. So let's do some examples. I'm going to erase this mess again. Almost. Okay. So let's do some examples. Let's do, write it down here, an example of an element that is in group 2, period 4. So group 2, that's this column, right? Period 4, that's this, so calcium. Let's undo those lines. So calcium is my example. How about an inner transition metal in period 6? And I'm just looking for one example, so what do you guys think? What's an example? Yeah, you have lots of options this time. So you could pick anything. Remember, this is the one that's part of period 6. You could pick any of those. So if you picked any of those, you're correct. If you pick something that's not one of those, then you got it wrong. Sorry. How about a semi-metal in period 5? So what do you guys think? An example of a semi-metal in period 5. Yeah, so again, remember periods are my rows. So 5, this is period 5. And then remember, semi-metals are the ones that are along that zigzag line. So I can pick antimony or tellurium. Either one of those would be correct. So these are typical questions. I could draw a sketch of the periodic table and have you label, transition metals, main groups, and so on. So do be familiar with those parts that we talked about, right? So know what groups are, know what a period is, know both of these numbering systems. You don't need to know the exact ones for Bs, but I do want you to know where the B block is. Right? The B block are my transition metals. Know where the inner transition metals are. Know where the main groups are. And then know where our metals, non-metals, and semi-metals are. And be able to give me examples of all of those.